a disk galaxy in the early universe, just 1.5 billion years after the Big Bang, somehow formed during a time of chaotic cosmic conditions. The galaxy we live in, the Milky Way, sports a rotating disk that extends across 100,000 light-years and contains billions of stars and planets. Scientists have estimated that this level of galactic girth, which is the signature of disk galaxies like the Milky Way, must take about 6 billion years to amass. That assumption has been upended by unprecedented observations of a galaxy that evolved a rotating disk just 1.5 billion years after the birth of the universe, challenging our understanding of the timeline of the formation of galaxies like our own. Known officially as DLAO 817G and informally as the Wolf Disk, this ancient and distant object sheds new light on the open question in galaxy evolution about the epoch at which disk galaxies like our Milky Way formed. According to a study published on Wednesday in Nature, massive disk galaxies like the Milky Way are expected to form at late times in tradition. The presence of the disk galaxy in the early universe is unexpected because, as Needleman noted in a statement, most galaxies in the early universe look like train wrecks because they are constantly absorbing clouds of hot gas that destabilize the disk. Models suggest that over a period of several billion years, this gas cools down, allowing the formation of a regular rotating disk, like the one Earth is currently situated in. That said, recent numerical simulations suggest that such galaxies could form as early as a billion years after the Big Bang through the accretion of cold material and mergers, according to the new study, though it also notes that observationally, it has been difficult to identify disk galaxies in the early universe in order to discern between competing models of galaxy formation. Needleman led the team that first discovered the Wolf Disk a few years ago, with the help of the late astrophysicist Arthur Wolf, for whom the galaxy is nicknamed. The team was able to spot this rare sight thanks to an extremely bright galaxy located behind it, from our perspective on Earth, which backlit the gas and dust around the Wolf Disk. Needleman and his colleagues have now followed up on the discovery by examining this faraway object with some of the most powerful telescopes ever built: the Atacama Large Millimeter/Submillimeter Array ALMA in Chile, Carl G. Yansky Very Large Array VLA in New Mexico, and the Hubble Space Telescope. The results confirmed that the object really is a disk galaxy, and constrained some of its key properties. For instance, the team clocked the rotation speed of the disk at around 170 miles (272 kilometers per second), a similar clip to the Milky Way. However, given that we are looking at this galaxy as it was some 11 billion years ago, it is understandably a lot smaller than the Milky Way, whereas our galaxy may top the scales at over 1 trillion times as massive as the Sun. The Wolf Disk, as we see it in the early universe, is about 72 billion times as massive as the Sun. Though the Wolf Disk may have evolved into a much larger galaxy by now, our view of it in the early universe is still unexpectedly big and stable for that era. Its existence suggests that a popular model of galaxy formation, which the study calls the hot mode accretion scenario, may not be giving scientists the full picture of how galaxies form and evolve. In this hot mode scenario, gas and dark matter are siloed into halos that form the central hub of the galaxy, which then gravitationally attracts hot clumps of gas that initiate star formation. In models of this process, it typically takes several billion years for stable disk galaxies to form because infalling hot gas tends to throw galactic structures into chaos. Another alternative, called cold mode accretion, may help explain the origins of early bird galaxies like the Wolf Disk. In this scenario, stable disks can form more quickly by attracting colder gas clumps and mergers, which do not disrupt the developing structure of a disk as much as their hotter counterparts. The existence of such a massive, rotationally supported, cold disk galaxy when the universe was only 1.5 billion years old favors formation through either cold mode accretion or mergers, said the team in the new study. The researchers wrote that there are still major unresolved questions about this cold mode scenario, noting that the Wolf Disk's large rotational velocity and large content of cold gas remain challenging to reproduce with most numerical simulations. In other words, this glimpse of such a well-formed disk galaxy, just chilling out in the early universe, demonstrates how much we still have to learn about the full backstory of galaxies like the Milky Way. Hello friends, I am VJ, and how was the video? Please comment in the box and don't forget to subscribe our channel. So thank you for watching.